Hello, this is the video for the special topics on data analytics. And we are going to learn about the recommender system. In particular, we are going to learn about the collaborative filtering. Okay. So this slide, we are going to learn about the collaborative filtering, and there are some section that I will put it in next week. So in this slide, we are going to learn about the pure CF approach, yeah. And we are going to learn about the user-based nearest neighbor, person correlation similarity measures. So you already learned before about the person correlation. And we are going to look at the item-based nearest neighbor, cosine similarity measures, and also the data sparsity problem. Okay, let's start with the content. So before we learn more about the collaborative filterings, now let's look at this data. Just a simple quiz to you. Using the below data, what is the possible rating of Charlie on item 4? Okay, let's look at this data. We have Alice, we have Bob, and we have Charlie. And we have item 1, item 2, item 3, item 4, item 5. If we look at this rating, it seems we have only 2 ratings, good or bad. So this is good, this is bad. Yeah, because there is no other kind of information. Yeah, we can assume like that one. And okay, we need to answer this question mark. So what is the possible rating of this item 4 of Charlie? Okay, now let's look at the data. If we look at the data, Charlie is, how is the correlation between Charlie and Alice? Okay, if you look at the Charlie's on item 1, Alice don't have any information about item 1. Okay, and about item 3, Charlie has the rating on item 3, but Alice does not have any information on item 3. Charlie has a rating on item 5, but Alice does not have any information about item 5. So it is difficult to use Alice data to know about the Charlie's rating. Okay. But how about if we use the Bob data? Okay, let's look at this Bob data. Charlie and Bob share the same rating on item 1. Okay. How about item 2? Okay, item 2 only Bob is available, but Charlie does not have any data. On item 3, Bob does not have any data, but Charlie has the data. Okay. So item 5, yeah, Bob has the data, Charlie has the data. Then, because of this contents, I can say that Bob and Charlie share similar data. Okay. Now, just let's look at the user. Okay. Because I know that item 1 for Bob and Charlie, they share the same rating. For item 5, Bob and Charlie share the same rating. For item 2, no information. For item 3, no information. For item 4, okay, we need to predict this one. Then what is the result? Okay, so maybe the possible rating for Charlie on item 4 is bad. Okay, so we can predict this one. Maybe the rating from Charlie is bad. So we are going to learn this collaborative filtering. This collaborative filtering is one of the prominent approach to generate the recommendation. It is used by large commercial e-commerce sites. So for example, in Netflix, okay, yeah, they use the collaborative filtering. It mentioned that it is well understood because it is easy to understand. And there are various algorithms and there are many variation access. And it is applicable to many domains. For example, if your data is about book data set, then yeah, you can apply this collaborative filtering on the book data set. If it is about movies, then you can also learn, you can use this algorithm for the movies and other things. Okay. So for example, in the Netflix, okay, everything is about a recommendation. So yeah, you can look at the Netflix display. Usually they will give a kind of title ranking, okay, and then yeah, you can select based on the order of the rank that they already put into this kind of user interface. And the approach is, yeah, it will use the wisdom of crowd. It means what the crowd mentioned, it is called as wisdom, and it is used to recommend the items. That's why when you enter the Netflix, they will ask you about your profiles. For example, what is your gender, and then what is your preference languages, and yeah, other things that can represent some information from the crowd. The basic assumption and idea is user give ratings to catalog items. So the catalog items means yeah, user give the rating to movie, okay, either implicitly or explicitly. So implicitly, maybe the user just visit or the user just watch the trailers. Explicitly means the user give rating. So maybe he or she gave 5 on that movie. Okay. So the assumption is customer who had similar tastes in the past will have similar tastes in the future. Okay. Now let's see in this example. I can see she, okay, she likes the movie, okay, and she also liked this movie. Okay, we have another user. This guy liked this movie. Oh, okay, this movie is the same, and he also liked this movie. Okay, because she and he share the similar movies, so they watch the movies and both of them like the same movies. So I can say that they are similar. Because they are similar, now you can look at the guy. So the guy liked this movie. So I can recommend this movie to this lady because they have the similar profiles or they have the similar tastes. We call it, this is the similar tastes in the past. So there will be a similar tastes in the future. So the input, okay, we need to understand the input. So when we learn about the data, the input will be user and ratings. User, items, and ratings. Okay. So in the pure CF approaches, the input will be only a matrix, and the matrix is a matrix of user, item, and ratings. The output will be a numerical prediction. Okay, a numerical means yeah, a number. So a number, it can be a rating number like 1, 2, 3, 4, 5. Or yeah, when you look at this example, yeah, we can say something like 1 and -1. One means good, -1 means bad. Yeah. So a numerical prediction indicating to what degree the current user will like or dislike a certain items. So if you use the like and dislike, then it means only binary, 0, 1, or -1 and 1. And the other kind of output can be a top and list of recommended items. It means after I know that I can recommend item 4, maybe this is bad. I don't want to recommend item 4. So I can recommend item 2 because Bob likes item 1, Bob likes item 2, Charlie likes item 1, Charlie like item 5, so I can recommend item 2. But it is only one item. I can list the items, maybe the top 5 items I can recommend to Charlie, or the top 3 items I can recommend to Charlie. So the n represent any integer number. So the basic idea of this collaborative filtering, we are going to learn one by one. The first part, we are going to learn about the user base. The user base, it is based on the user, and we call the nearest neighbor. The nearest neighbor means I want to see the nearest user. Neighbor means the person who are close enough with someone. Okay, so the basic technique like this one, in this example, I have an active user, and the active user I call Alice, and there is an item I not yet seen by Alice, so this is in the question mark. Now if I have this kind of matrix, can I predict what is the rating that Alice will give to this item 5? Now, that is the question. And using this basic technique, we are going to learn about the user base nearest neighbor. So the method that we are going to learn here is find a set of users. A set of users. It means not only one user, but it can be more than one users. What does it mean by users? It can be peers, or maybe it can be your friends. We can find the nearest neighbors, the nearest or the closest neighbors who like the same items as Alice in the past, and who have rated item I. Okay, so this means that I want to know other user which is closer to Alice, and because I want to predict item 5, so all the users that I want to calculate should have the rating on item 5. Okay, so if the item 5 has no rating, then we cannot consider this user. If no rating on item 5, that's the meaning. Okay, so use, for example, the average of their ratings to predict if Alice will like item I. So if I know the numbers, then I can know the average. I can know the average of their ratings. And you can do this for all items Alice has not seen and recommend the best rated. So I can recommend what is the best possible rating value. Right? I can recommend the best possible rating value for Alice. Okay. So the basic assumption and idea, if user has a similar taste in the past, they will have similar taste in the future. So that's the basic assumption that we have before. Okay. And there is another kind of assumption. User preferences remain stable and consistent over time. Okay. So because if the person suddenly have another kind of emotion because he left his job, so he has some stress, he is a kind of depression, so maybe he wants to watch comedian movie more than his own preference. And this is also consistent, maybe because he wants to try something new movie, so there will be inconsistent. So if it is not consistent, we cannot use this one. Okay. So the example that we have before is this one. We assume that we have a database of ratings of the current user. So this current user, we assume that there is no missing value. Okay, this is a very good data. A database of the current user, which is Alice, and some other users. So we already select only these 4 users are good for the Alice prediction. Okay. So I want to determine whether Alice will like or dislike item 5, which Alice has not yet rated or seen. Okay. So there's first question. Okay, before we do the calculation, I want you to learn about this one. First, how can we measure the similarity? It is a first question. Okay? And how many neighbors should we consider? So the similarity, it means I want to know whether Alice is similar to user 1, or Alice is similar to user 2, or Alice is similar to user 3, or Alice similar to user 4. It is 1 by 1 or pair. But how many neighbors should we consider? Should I consider Alice and user 1 only? Or should I consider Alice and user 1 and user 2? Should I consider Alice and user 1, user 2, user 3? Or maybe Alice and user 1, user 2, and user 4? Okay. So if I consider 2 neighbors, then I will consider 2 users. If I consider 3 neighbors, then I will consider 3 different users. Okay. And the other question is, how do we generate a prediction from the neighbors rating? I know that user 1 and user 2, for example, they are close to Alice. But how can we predict this number? Okay, those kind of question will be the one that we learn today. So for the remaining, I guess I will put into the class. So in this example, I'm going to use the Pearson correlation, and the details for the Pearson correlation we will discuss more in the class. Okay, see you on the class and have a good day.